we always complete the square, but not with the leading coefficient other than 1. So these two have 4. So this is x squared minus 8x. And I have to add and subtract. And then the second one, the second part for the y, 36 y squared minus 10y, and plus and minus, and then plus 864 equals 0. So what do we add and subtract? For the, yes?
Wouldn't it be x squared minus 6x rather than 8x?
Oh, yes, it's 6. Thank you, thank you. Thank you. Of course, I factor out 4. It's 24. I'm checking now. I don't trust myself anymore. So yes, that's okay. So what do we add and subtract? Negative 6 divided by 3 is negative 3. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So we have to add and subtract 9. Negative 10 divided by 2 is 5. And we have 25. Is this okay? I'm sorry?
Can you go through that process one more time?
The middle coefficient divided by 2 square, and that's what you add. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. That's what we need to add. Negative 10 divided by 2 is negative 5. We square negative 5. That's what we add. Say it again, Caleb.
Well, it's the same as finding the vertex of a thing, right?
Finding the vertex for what?
Vertex, isn't it like negative b over 2?
But that's negative b over 2a. I'm not dividing by 2a. Oh yeah, actually in a way you're right. I see what you mean. That's how the vertex was determined, by completing the square and factoring out the leading coefficient. Yes. Yes. Very good point. I agree completely. So then 4, what is this replaced by? Bailey, can you please? X minus 3, everything squared, and minus 36, plus 36, y minus 5 squared, minus 36 times 25, and plus 864. Is this okay? Is this okay? Do we understand?
Why is it minus 36 over 5?
So I have to distribute 4 after I complete the square, and I have to distribute it to negative 9 as well. I have to distribute 36 after I complete the square, and then 36 has to be distributed to negative 25 as well. And then plus 864. I skipped one step just because I would like to continue with hyperbola, but I have to answer your question. So then, is this okay, everyone?
Yes.
Good, so now I have, where's my calculator? So what do we have there? We have 864, and then minus 36, and then minus 36 times 25. Is there anything left? Did you get 72? Okay, so we move for 72, it's negative, so we move 72 to the other side. Obviously, we have to divide. 4x minus 3 squared divided by 72 plus 36 y minus 5 squared divided by 72 equals 1. This is absolutely mandatory. Otherwise, if we don't have 1 on the other side, it may still be an ellipse, but we will not be able to identify A and B. The major axis and the minor axis. Okay, so we'll simplify. What do I simplify? So 36, so divided by 2, I think it's 18, is it? And this is 2. Is that okay?
Yeah.
Okay, so then x minus 3 squared over 18 plus y minus 5 squared over 2, equals 1. So then please give me the center of this ellipse, and a squared and b squared, and at least it's the calculations for the foci are not required. It was just an idea I had. So, and also tell me whether it's on the major axis is on the x-axis or on the horizontal or vertical. Yes, again, it's a horizontal situation, and the coordinates of the center are 3, 5. Okay. The next one is the hyperbola. Any questions? Are all our numbers okay? Yes. Sarmad? You may see something that I don't.
Shouldn't be the, two?
Oh, yeah. So A equals 3 the square root of 2, and B equals the square root of 2. Thank you for, yeah. Anything else? Okay. Hyperbola. Here's the equation of the hyperbola. X squared over A squared, but minus Y squared over B squared equals 1. Of course, X minus H squared over A squared minus Y minus K squared over B squared equals 1 is the shifted. This one has the center at 0, 0, and this one has the center at H comma K, of course. How does a hyperbola look like? And how do we determine it? And I just wanted to show you an example where it is, you are going to see it, and I'm sure now moving on forward, you're going to be able to identify a hyperbola. So here's a tower, and this is the hyperbola. Of course, it's not a function, it's a conic section on both sides. And it has a rectangle in the middle, which could be a square. So here is how it looks like. Where will the foci be? Right here. And this time, all points on the hyperbola are not found at the sum that is equal, but a difference that is equal. So this point is this point on the hyperbola is found at the same distance from the foci, but it's a difference that is always constant, not a sum. Okay. So let's take a look at how we graph this. And there are, of course, two possibilities. This time we're not going to call the major axis and minor axis like we do for the ellipse. We're going to call it the transversal axis and the co-axis, vertex and co-vertex. Just something that is different. Bless you. Okay, so everything is the same situations, it's just that the graph is different. Everything is the same, we're going to choose the same type of problems. We're going to graph a couple, and then, of course, complete the square. So that's why I was saying we can do two problems from ellipse or wait till we look at, okay. So let's look at a simple situation like before. And then slightly more sophisticated. And then since we already know how to complete the square, we understand that now we can directly go to a shifted hyperbola. So let's start with this one, number 7. So 7 on page, makes me laugh whenever I write 1011 on any pre-calc and below class. It's just, there's no need for that. That's my opinion anyway. So I look to see what type of examples, because I know that you're going to have something similar on in WebAssign. And because I browsed this this book, so on the hyperbola section on page 998, it says deriving the equation of an ellipse. We're not talking about ellipse in this section, so we're talking about hyperbola. So we're not deriving the equation of an ellipse. Also, it says the sum of the distances, which is not the sum, is the difference. They calculate the difference, but they say the sum of the distances, which is not the case. It's the difference of the distances, so pay attention. So don't believe everything that you see in this book.
What's the equation at the top?
Say it again.
What's the equation at the top of the page? There are two equations in the top. Okay.
So it's the same, but with minus. Everything is the same, but just minus in between. That we looked at the ellipse. Better? Very good. So this will be, of course, a squared. This will be our b squared. A, of course, will be 6. B, of course, will be 3. What is the center of the hyperbola? We don't even know how to graph it yet, but we already know the center. What will be the center? Yes, we start with a simple example, centered at the origin. Okay, so let's take a look. So here's how we built this. Okay, so centered at the origin, A is 6, so I go 6 to 4, 5, 6, 1, 2, 3, 4, 5, 6. Of course, negative 6 and positive 6. B is 3, up 3, down 3. And now we will create a rectangle, which is not part of the graph. So please do not graph it as a solid rectangle. This rectangle will only help us graph the hyperbola. And also the hyperbola has asymptotes. They're not part of the graph. We will graph the asymptotes. Ready? The asymptotes go from the second to the fourth quadrant and the first to the third. They have to go through the corners to the center of the hyperbola and the corners of the rectangle. They are not solid lines like any asymptotes. They're not solid lines. The same thing. Both corners, opposite corners, going through the center. Always. These are the asymptotes. And now finally we can graph the hyperbola. Ready? This is the vertex, and this is the other vertex, because the transversal axis is horizontal. If the transversal axis is vertical, then the hyperbola will go this way, approaching the asymptotes, not going further away from the asymptotes.
If it's transversal versus what?
If it's on the y-axis.
So
If the bigger the
B is
balloon.
Right, right. So let's graph. Make sure that the hyperbola gets closer and closer to its asymptotes. And the same thing on the other side. And this is the hyperbola. Would you like to complete another square, or can we move on to, let's also do 9 before we look at anything else. So let's say 25x squared minus 16y squared equals 100. Yes?
So this minus 6 and 6 is called the vertex?
Yes. So this vertex is negative 6 comma 0, and this is at positive 6 comma 0. Yes.
And what about minus 3 and 3, these 2 points?
Nothing. They're not part of the hyperbola. I need that box in order to be able to correctly graph the hyperbola.
You use another term like what's
It's the co-transversal, co-axis. This is the axis and this one is the co-axis. So you can call these co-vertices. You can. But they're not going to help, they're not going to be part of the graph. They're just going to be part of the rectangle that helps us graph it.
it's just because of A is greater
They
than
are
B?
called co-vertex, yes. Co-vertex 0, 3, co-vertex 0, negative 3.
So in case of B, B is greater than A, in that case.
Then it's going to be on the vertical axis, yes. And these will be vertices and these will be co-vertices.
Okay.
Very good. Okay, so what do we do with this? We're asked, in this example, we're asked to identify the vertices. Write it in standard form. That's the first thing. What should we do? Knowing that, so let's write the standard form for a hyperbola centered at the origin. So x squared over a squared minus y squared over b squared Yep. Equals 1, of course. Now, how will the other one look like? Y squared over b squared minus x squared over a squared equals 1. If it's on the y-axis. Okay, so what do you think we have to do here, like we did before with the ellipse? The same thing. Divide by 100. So 25x squared over 100 minus 16y squared over 100 equals 1. And we will simplify. So this will be 4. And when I divide by 4, what do I get? 25. Okay, so then I have x squared over 4 minus y squared over 25 over 4 equals 1. How much is a squared for the hyperbola? Yes. How much is b squared? Any questions? So then a is 2. If you want to graph this, you can. So it would be from 2 to 2 and from 5 halves and 5 halves, right? 2, 2, 2, 2. The square root of, so this is 5 over 2 and this is 2. Okay, in that case, what's going to happen? So a squared equals 4, which means a equals 2. And then b squared equals 25 over 4, which means b equals 5 halves. Since this is bigger than this, let's graph it. So we see one like that. Okay. It is still on the x-axis because x squared has positive in front and y squared has minus in front. Okay, so that doesn't change. But the box can be what I call the box, the rectangle. Doesn't have to have the transversal axis longer than the co-axis. So, and it doesn't in this case. So 2.5, 2.5, 2, and 2. I create the rectangle. It's not part of the graph. I draw the asymptotes through the corners, the opposite corners, and through the center. And now I'm able to graph the hyperbola. Make sure that it's approaching the asymptotes. As we know, that's the reason, or that's the meaning of the asymptotes. Okay, let's look at a by the way, how do we determine, I want to mention that too. Well, in this case, c squared is not it's a squared plus b squared. Remember, yes? Remember for the ellipse, it was a squared minus b squared, yes.
So since the b value is bigger than
It doesn't matter. If it is the negative in front of y squared, it's still on the x. So that the numbers do not matter. As long as the one that has a minus in front has to be the minor. Yes. Okay. Would we like to identify, let's identify, basically, I would like to go through one example like that first, because before we identify. What do you think about this? Bless you. For the following exercises, find the equations of the asymptotes of each hyperbola. By the way, what is the center? Yes, 3 comma negative 4. The center is 3 comma negative 4. Okay. Then A is 5 and B is 2. Would you agree with that? Okay, perfect. So if I were to graph this, I would have to plot the center first. 1, 2, 3, 1, 2, 3, 4, right here. You already told me that A is 5. 1, 2, 3, 4, 5. 3, 4, 5. And B is 2. 1, 2. 1, 2. So here's the rectangle. We don't have to graph. Of course, I will graph. But we're asked to determine the equations of the asymptotes. So here's the graph of the hyperbola. It has minus in front of y, so it's still on the x horizontal. So here is the hyperbola. By the way, you're not going to see these in Calc 1. You're going to have to wait till Calc 2 to see these again. Okay, perfect. So we are only asked to determine this equation. Well, this is 3 comma negative 4. Once I identify one more point, I can determine the equation of the asymptote. Yes, I can give you the formula, but I think it's better if you just understand how to determine it, right? So can anyone give us this point? Well, we have it, right? So this is 5, and this is 2. 5 and 2. Can anyone identify this point? So 5 to the left of 3, so this is negative 2, and up 2 from negative 4. So this must be negative 2. I have 2 points, and I can determine the equation of the line. So the slope will be negative 4 minus minus 2, negative 4 plus 2, over 3 minus minus 2. So 3 plus 2. So it's negative 2 over 5. And now I have y minus y1 equals the slope times x minus x1. So the slope is negative 2/5. And I plug in, let's say, negative 2, negative 2. I determine the equation of the asymptotes. So then one of them, and then I can determine the other. So y plus 2 equals negative 2/5 and x plus 2. And then y equals negative 2/5 x minus 4/5 and minus 2. So y equals negative 2/5 x minus 14 divided by 5. It's much easier when the center is at the origin, of course, because you just have rise over run and nothing else. And it does not have a free term, of course, but in this case, slightly more difficult.
Do we have to find the asymptote the other way as well?
What do you mean by the other way?
If there's one going with the-
Oh yeah, the other one you mean, yes. Yes, when we're asked to find the asymptotes, we are asked to find both. Yes. Is the method clear? Is it clear how we determine the asymptotes? Okay. So what about the foci? Foci are here. F1, F2. I don't know exactly where, right? But that's where they are found. Somewhere inside this, these are the vertices. So this is V2 and this is V1, vertex 1, vertex 2, and these are the foci. So how we determine the C, right? Because this time we have C squared equals A squared plus B squared. So let's determine for this one. Because then I would like to just determine one of the equations. So just look at any of these and determine the equation. Okay. So obviously the y coordinate, the height has to be the same, which is negative 4. No question there. And we just have to determine C. So where it is. But we have to find C. So C equals a squared plus b squared. So c squared, what was a? A was 5, b was 2. So 25 plus 4. So this is 29. So then C equals the square root of 29. So again, I have to determine, so from 29, I have to subtract, so from the square root of 29, I have to subtract 3 to determine this. So what do we get? So F2 will have -4 and the square root of 29 minus 3. What is that? I'm just going to write it as is. So the square root of 29 minus 3. What about this one? So it has to be the same distance. This distance has to be the square root of 29, because that's what C is.
What did you do?
This is 3. This is 3. So this is the square root of 29 minus 3. The square root of 29 plus 3, actually. Yes, okay. Okay. Yes. And on the other side, hold on. Yes, on the other side. But it has to be negative, so careful. So the square root of 29 plus 3, and for F1 is -4, but it will be
-29.
negative the square root of 29 plus 3.
Is it minus?
So this distance has to be the square root of 29, because this one is the square root of 29 as well, right? So the square root of 29, and I subtract -3, right? So that's going to be negative the square root of 29 plus 3. Is that correct? Okay. Let's take a look at one graph. You choose any graph you want, and let's, yes, please.
Could you please show there is C in that graph?
Say it again.
There is C on that graph. On the graph.
C on this.
Yeah.
So this is C. But the position of this point is the C plus 3 for the x. So this is the square root of 29. But the position of this point is at square root 29 plus 3. If you shift it here and it's here, then the distance will be the square root of 29. But it's shifted to the right 3 units. Better? Okay, so let's choose one example from here.
53.
Which one?
53.
Okay, so in 53, obviously the negative has to be in front of x squared because it's on the vertical. Okay, so we have the center. So let's start by writing a few things. So we picked 53. And 53 on page 1012. Okay, so we know that it's going to be y squared over a squared minus x squared over b squared equals 1. Negative in front of x means it's on the vertical. We have y minus it's 1 minus k squared over a squared minus x minus k, of course, squared over b squared equals 1. We have the center is given to us at -1, 0. So we know that this is -1 and this is 0. We agree with that? Center -1, 0. So then for now we have y squared over a squared minus x plus 1 squared over b squared equals 1. So that's the information we have from the center. We are told that the vertices are -1, 3. So if the vertex is -1, 3, I know exactly what is A. Or the number under y, in other words. What is it?
3.
3, very good. Okay, we don't know what is b yet, but we know that the foci, one of them is up here. It's of course on. It has the same x value as -1 as the center, -1. But this distance between 0 and this point, this distance is 3 to the square root of 2. So c equals 3 to the square root of 2.
C not the center, C having the foci.
C being the distance, vertical distance between the center and the top focus. So this is C on the y-axis, which is 3 to the square root of 2. If that's the case, and knowing that c squared equals a squared plus b squared, from here we will be able to determine b. So when I square 3 to the square root of 2, I get 9 times 2, which is 18. A squared is 9 plus b squared. So then b squared equals also 9. So b equals 3. So it happens that that rectangle is actually a square.
Could you explain how you found A?
Yes.
From that graph.
Yes. Okay, so I know that this is the center, and I know that this is the vertex. This must be the length under y squared. And I see it, it's 3. So that's A. I don't know B. I don't know where the box is going.
So A equals 3 squared, then?
A squared is 9.
Mhm.
Yes. So A is 3, as you see it here. 3 and 3. So A is 3, so I will have definitely whatever y squared, some squared, perfect square with y, divided by 3 squared, which is 9. Once I know that C is between these 2 points, and that must be 3 to the square root of 2, I have C and I have A, I can determine B. Is that better? Yes.
How did you get C?
Because I see the focus is here, and the coordinates of the focus are -1, 3, the square root of 2, which means that this height is 3 the square root of 2. Better? Perfect. So then I have c squared. When I square this, I get 9 times 2, which is 18. I have a squared, which is 9. And then b squared must be 18 minus 9, which is b squared must be 18 minus 9, which is b squared equals 9. So then b equals 3. If b equals 3, then I have the entire equation, which is y squared over 9 minus x plus 1 squared over 9 equals 1. And this is the equation of the hyperbola in the picture. Yes, please.
So, if we put b square under x plus 1,
Because the center is -1, 0.
so wherever is the negative sign is, we have to put b with that.
So the general formula is y minus k everything squared over a squared minus x minus h everything squared divided by b squared equals 1. If the center is -1, 0, I get y minus 0, which is y squared over 9. I get x minus -1, which is x plus 1 squared, divided by 9. Is that what you are asking?
Alright, so my question is like if we have minus sign there, like with x plus 1,
Here.
no, with x plus 1 we have minus sign, right?
Yes.
So that's why
But
we have
if,
b
but
square.
if the x coordinate of the center is -1, when you plug it in, you get x plus 1. Is that okay? Is that what you're asking?
Okay.
Now, if the center were 1, 0, I would have had x minus 1. But the center is negative 1. So I have to put in the center as is.
And that's why our a square is now b square and b square is a square. That's why we change a square to b
No,
square.
no. So the change is here if it's on the vertical. Meaning x will eventually have minus in front instead of y. I think I understand the confusion. So if it is on the vertical axis, x will have negative in front. As you see, this term follows the y. Y has positive, x has negative. If it is on the x-axis, then this will be positive and this will have negative. One of them has to have negative in front. But the center does not change. So this is the same thing as with